All right, so here we are again talking about balancing chemical equations. This is not new information. We're still going over it. We learned this on Friday. We talked about it on Monday too. This is a note set. It's already written for you. So I'm going to read through this, go through the rules, and do a couple examples. But for the most part, you are responsible for doing this. We'll do these together. And then you're going to do both parts of the balancing chemical equations practice on your own at home, following the steps. So one of the fundamental principles of chemistry is that matter cannot be created or destroyed. That's the law of conservation of mass. That means that during a chemical reaction, the sum total of all the reactants must equal the sum total of all the products. The elements may form new compounds, but the sum total of the elements at each side of a chemical equation must be equal. We have some rules for balancing chemical equations. All that first paragraph is telling you is the law of conservation of mass. That means that what's on the reactant side must be present on the product side. That means if I have a carbon in my reactants, that I've got to have carbon in my products as well. Our first rule for balancing chemical equations is that the sum total of all the reactants must equal the sum total of all the products. If there is a subscript in an element or compound, that applies only to the element it is attached to. For example, if I have H2, I know that we have 2 hydrogens. Remember, our subscripts tells us how many atoms there are. If I have PO4, that tells us that we have 1 phosphorus and 4 oxygen. So the 4 is only applying here to the oxygen. And then this is one you probably haven't seen before. I have magnesium, and I only have 1 magnesium atom because there's no subscript right here, bonded to OH, but parenthesis 2. Anytime you see a parenthesis, remember we are adding in that subscript to each of the parts. So the subscript goes here by the H as well as here by the O. So this is telling me that I have 1 magnesium atom, 2 oxygen atoms, and 2 hydrogen atoms. Rule number 3, you may add numbers in front of elements or compounds to help you balance. These are known as coefficients. These are our big numbers. If there is no coefficient, it is understood that there is 1 mole of that element compound, or you only have 1. You cannot change the formula of the compounds and the equations or the subscripts they have. That means that the only thing you can do is add a coefficient in front of a compound to balance your equations. For compounds, adding a coefficient in front of the compound means that you have that number of each element in the compound. For example, if I have 3 right here, that means I have 3 sodium atoms and 3 chlorine atoms. For elements or compounds with subscripts, multiply the subscript by the coefficient. So if I have 3 hydrogen, sulfur, oxygen atoms, I have 3 times the 2 on the subscript of the hydrogen tells us how many hydrogens we have, or 6. 3 times the sulfur atom, we have 1, so 1 times 3 is 3. And 4 oxygen atoms times 3 is 12 oxygen. Same thing can happen here. We've got 4 times the aluminum, 2, means that I have 8 aluminum atoms. If I go over here, I've got sulfur, but remember we've got to add this subscript first. So 2 times 4 is 8, so this would be an 8 by the oxygen, and 2 times 1 is 2, so I'd have a 2 near my sulfur. So I've understood 2 right here by my sulfur. 2 times 4 is 8, so I have 8 sulfurs. And then remember we have 2 times 4 is 8, so times 4 again is 32 oxygen atoms. Rule number 4, start by balancing the largest compounds first and leave any individual elements to the end, especially hydrogen gas or oxygen gas. If you balance an equation and there's a common factor among all the numbers in front of the compounds, divide by the common factor. So see here, we have 3 as my common factor. Each of these numbers can be divided by 3. This isn't the simplest it can be. To simplify, it needs to be 2, 1, 2. You might only add whole numbers to coefficients if you reach a point where your equation will be balanced with a half as a coefficient. Temporarily place it there and then multiply everything by 2. So for this one, we're just not going to put any fractions in front of our coefficients. We just will not have that happen because it's going to confuse you. So let's try to balance this equation. So I've got how many hydrogens atoms plus how many oxygen atoms is going to take to yield my water atom. To start, there is 1 mole of hydrogen gas and 1 of oxygen gas and 1 of water. The left side of the equation has 2 hydrogens, 1, 2, and 2 oxygen atoms, 1, 2. The right side of the equation has 2 hydrogen atoms, 1, 2, and only 1 oxygen atom. That means that this is not balanced. The first thing I'm going to try to do is add a 2 right here to try and balance out that 2. We've done this one before. If I put a 2 right there, though, that balances my oxygens because I have 1, 2 on the left side, or the right side, and 1, 2 on the left side. But now my hydrogens are mixed up. I have too many of those. So I have 1, 2, 3, 4 on my product side and only 2 on my reactant side. That means I need to add an additional coefficient to this equation. We know that we would add a 2 right here next to my hydrogen gas molecules. And then we have finally balanced the equation because we have 1, 2, 3, 4 hydrogen atoms on the reactant side and 1, 2, 3, 4 on the product side. Then we have 1, 2 oxygen atoms on the reactant side and 1, 2 oxygen atoms on the product side. Now we're going to try and do this together. We're going to try and balance these equations. You have 2 pages to balance. It should be no problem for you all. You've got plenty of time after this video lecture. Remember, the first thing that I would do, and you should do, is list the number of atoms present of each type. So if you were to do that, you have 1 carbon atom, so C would equal 1. You have 4 hydrogen atoms, H would equal 4. And you have 2 oxygen atoms on the reactant side, O would equal 2. Then I would do the same thing over here on my product side. Got 2 hydrogen atoms, 1, 2, 3 oxygen atoms, and 1 carbon atom. So you know that this is not balanced. You need to figure out how to balance them. Good luck. These are tricky, but the first step in all of this is to list what you have. Then you need to try and balance them out. You'll keep going until you get what's on the reactant side to equal what is on the product side. If it does not equal, then you know you haven't done it. This would be a great activity to try with a friend, especially if you're stuck. We're going to do both these and this page as well. If it happens that my students in class are struggling and they can't get it all done, I will extend the deadline until tomorrow. Good luck. Remember that our parentheses we need to multiply in. So like for this one, I would actually have 2 oxygen atoms because of this 2 and 2 hydrogen atoms because of this 2. Good luck.